Assalamu alaikum, sir.
Assalamu alaikum. Can you see the slide?
Yes, sir.
Okay. Am I audible?
Yes, sir.
Yes,
You
sir.
are
You're audible, sir.
Okay. Alhamdulillah. So this is first class of engineering materials of my part of the class. Credit hour is 3. By this time you know because you had some classes conducted by Dr. Farooq. So this course will be taken mainly by me and Lieutenant Farooq also. Okay. And then let's see what we have. So these are the reference books which I'll be using time to time. One commonly, these few of the books are available in the library. You can issue. There is a book of Dr. M. Aziz, Engineering Materials, a very basic one. And normally it deals with traditional engineering materials. Also, the book of Gucharan Singh or book of Kulkarni, those two Indian writers. So these 3 books actually deals with traditional engineering materials. And then the books of Neville, actually, that material 4 and 5, actually, the more concerned concrete technology, the properties of concrete, actually, which will be taught by Mr. Farooq. You can have these books also available here. Corrosion Engineering, this is a book by Mars G. Fontana. This topic will be covered by me. Very less number of books are there, but I'll give you relevant lecture sheets from this book. And for metallurgy, there is one book, and then chemistry of engineering materials. So this is a book written by a Bangladeshi professor. So it also deals some part of cement, then corrosion, which will be covered from there. Engineering metallurgy with corrosion part of materials will be covered from there. And there is a book dedicated for cement, structure and performance of cement. The last one. So these are the books actually time to time we'll be consulting. Class plan. So in engineering material, we have got various types of materials. We'll be going into the details, but just see the lecture plan. The first one is the properties and use of aggregates. We'll have 3 lectures on that. Then on cement, we'll have 3 lectures. Then once you have sufficient knowledge on aggregate and cement, that will help you to understand the concrete part, which will be taken by Lieutenant Farooq. Then one lecture will be dedicated for ferrocement. So ferrocement is a type of a structure. Basically, this is a thin shell structure. Nothing extraordinary. Normally, in case of reinforcement, and very thin reinforcement bars are used and cement are used, but actually the materials are not different, but the construction procedure is different. And there are some structures which are made of ferrocement. So we'll have one lecture dedicated for that. Then nowadays, one commonly used material is FRP. That means fiber reinforced polymer or fiber reinforced plastics. So then FRP can be mixed with other commonly used materials, or it can be used independently. So we'll have 2 lectures on this topic. Topic 5, that means lecture 10 and 11, which is related to basically the properties of material, mainly actually steel. So actually steel means the mild steel, the reinforcement bar, or the rod that we commonly know. So we'll be learning few of the properties like strain conditions, then elastic behavior, elastoplastic, then elastoplastic behavior, how do they behave, okay, and also then creep response, the force relaxation, this type of terms, okay. So we'll be learning, we'll have 2 lectures, okay, in topic 5. Then we'll have 2 lectures for steel and aluminum. Aluminum we don't use much, but we should have some idea, and steel we should be thorough. Then one important issue is corrosion. Okay, so in corrosion, actually, I have got 2 lectures: the corrosion and prevention of steel in reinforced concrete structures. Okay, so this is a burning issue because the reinforced structures, concrete structures that we see nowadays, most probably the buildings are made before 70 to 80 years. At that time, people could not predict that how will be the interaction of the reinforcement rod with concrete and how it will deteriorate over the period of time. At that time, it was not understood, but then after use, nowadays, people try to understand its behavior, because the old buildings actually over the period of time, due to the corrosion, they are being deteriorated. So, and with that, there are some offshore structures. That means the structures that which are built near the shore or maybe offshore, away from the shore. So, how to prevent? What is the corrosion mechanism? How to prevent that? We'll have 2 lectures on that. Then one of the new material that is actually the technology is nanotechnology, and how we use this nanotechnology in cement and concrete. We'll have 1 lecture on that. And then nowadays you'll be hearing one term related to engineering material that is called the green building or green materials. Okay, so we'll have 1 lecture for that. Then one high performance material like engineered cementitious composites. So that is another name is bendable concrete. So we'll have 1 lecture for that. One special type of material is that is a smart material, that is the shape memory alloy. Okay, so we'll have 2 lectures on that, and we'll have a small lecture about offshore structure. That means what are the offshore structures are, and normally what are the materials are normally used. We'll have a brief discussion, and actually we'll see that how corrosion can be prevented in case of offshore structure. So that makes total 21 lectures. Okay. And on the part of Lieutenant Farooq, he'll be covering brick, sand, lime, mortars, concrete. So I hope that by the time he starts with concrete, we'll be able, we'll try to finish at least the aggregate part and cement part. So that with that basic knowledge, so that once he starts concrete, you will have some idea. And this is the part, these are the issues which we'll be covering in this part. Rationale of the course. So let us define engineering materials. So any materials which has got application in engineering construction, so it is termed as engineering material. Okay, in the book of M. Aziz, okay, first 3 or 4 pages. Okay, so here he outlined that why should we learn engineering materials? Okay, those things are being described in the book of Mr. M. Aziz, because you know that over the passage of times, the requirement of engineering materials for engineering applications, actually these are becoming complex day by day. Okay, because the concept of using engineering materials before 5 decades, then before 3 decades, and now are different, because there is always an effort to increase the efficiency of commonly used materials, and also to invent new materials, so that the main what we want, what is our expectation in the engineering materials, that they should have enough strength, they should be safe, they should be environment friendly, and then they should be okay, they should be cheap. Okay, and then if the strength is more, they will be carrying less space. So things are getting complicated day by day and challenging. And according to that, to suit to match with that requirements, actually those who work with the materials, okay, in case of civil engineering field, Okay, and actually, these materials are used in other engineering also. Many of the mechanical engineers they use, and then okay, in some other fields also the materials are used. You know, in BOIT there is a department, a metallurgy department. So they deal with the metal part. Okay, so that is all together. They have a separate department. So okay, in our this course will be actually confine ourselves with the commonly used materials which are used in civil engineering constructions. So nowadays, besides traditional engineering materials like brick, stone, cement, sand, then reinforcement bar, normally this is mild steel. Okay, these are the commonly used engineering materials. But besides those materials, there are so many materials that are coming up. Okay, because research is on to increase the strength, increase the durability, to make the material environment friendly. So due to these regions, actually diverse materials are coming up, okay, in the market, and that's why as a civil engineer, okay, you should have a thorough idea about the behavior, how the material will behave, okay, and what are the properties of material. What is the properties of material? So properties of material means property. What is the property? Property is the quality which defines specific characteristics of a material. Okay, actually, this property provides the basis that means basing on which we can predict the behavior of the material under various conditions. Like there may be some physical properties like size, shape, density, porosity, like that. There may be some mechanical properties like strength, elasticity, plasticity, stiffness, ductility. So we'll be coming across these terms, okay, in this course. There may be some chemical properties like corrosion resistance, alkalinity, chemical composition. So corrosion resistance we'll be talking, which is there in our syllabus. There may be some thermal properties. Thermal properties include a specific heat, okay, and then thermal expansion, because the materials that you'll be using, whether it is susceptible to temperature change or not. So that is also important in some of the constructions. The negative properties like the permeability, cohesive forces, electrical properties like conductivity, then okay, and then okay, those are the issues. So these are the properties we should know. So once we learn engineering materials, we'll be coming across about those properties. And there are variational properties. So some material under a given condition behaves in one way, and the same material maybe in other conditions. For example, if you take the example of a building, okay, so in the building there are there are superstructure which is above the ground, there is substructure which is below the ground. Same material behaves differently. Okay, maybe the material properties changes because the environment is different. So for same material there may be various properties, and then same material once it is used in the hot climate area, it behaves in one way. And same material when it is used in a cold climate area, it behaves in another way. So, and as an engineer, you'll be engaged for planning, for design, and for construction. So, if you are an engineer who is involved in planning, then for example, you are in charge of planning for a bridge or dam or road or water purification plant. Once you talk about engineering materials, don't confine yourself only to the building or bridge. There are okay, the beauty of actually the civil engineering that you have got variety of structures. But one thing I must tell you that you should give your attendance. Okay, you should give your attendance and then with the roll number clearly written and name. Okay, because later on from the chat box I'll collect your attendance and I'll update in the AppCam. So don't forget to give your attendance in the chat box. Okay. So you may be in charge of planning or okay, and then designing the construction of a bridge or dam or road or water purification plant, or maybe a sewage treatment plant, maybe a construction of a airfield. And nowadays in our country, some new things are coming up, like the construction of MRT. So MRT, the materials which are used in MRT, and the materials which are used in case of normal flyovers, or the gate separated intersections, the interchanges, these are different. Then MRT is coming up, then the tunnel. That means that in Kanafuli there is a tunnel is being constructed, and then in case of you must be knowing by this time that MRT6 work of MRT6 is going on, but in case of MRT5, which will start from Gaptoli, which will go to Milpur 10, and then it will finish somewhere near Gulshan, and it will go beyond that. So some part of the MRT6 is above the ground all along, but MRT5 some part will be below the ground and some part will be above the ground. So you see, you have to use different types of materials if you are involved in MRT5, because those part which will be underground, so there will be stations, MRT stations underground, so it will be requiring different types of materials. Okay, and then MRT, then that feasibility study of subway is going on, and then if those subways are constructed after feasibility study, if found feasible, that means that will be fully underground. So the material requirements will be different. So what I want to say that as an engineer, okay, you don't there is no scope of knowing superficially about the materials. So the project where you work or the design or the planning or construction of a specific engineering project, you have to choose or you have to dictate as an engineer the right type of material which has got the right type of strength which is suitable for the particular project, and you should make a combination of actually economy and the ability of materials and other things. Now that means you have to choose the appropriate type of material. Now in some construction, you'll be in dilemma whether it should be a concrete based construction, or it is a steel based construction, or it is a combination of both steel and concrete, and some other new products are coming in the market. So all those things actually you should know. So once you have a thorough understanding of the materials, then that will help you, okay, for planning, for design, or for constructions. Now for each type of material, normally for conventional materials like cement or concrete, okay, or for example sand, okay, stone chips. So there are some specific guidelines are there from STM, from ASTO, okay, British standard is there, okay. In case of our country, okay, in BNBC, and then in case of specific agencies like RSD, so they have got some specifications. So in the specifications, actually the requirements, the properties, desired properties of the materials. So those are mentioned there in the specifications. That means when you use some material, you have to maintain the quality of the material. So how to maintain the quality of the material? So the quality of the material will be done, material will be ensured through different types of tests. Some of those tests will be conducted in the laboratory before use, and some of the tests will be conducted once actually the construction is made. Okay, so you have a sessional in solid mechanics lab and material concrete lab, while you will have some idea about those type of tests. So as an engineer about the materials, you should have idea about those issues. So okay, this slide says that okay, the modern buildings, what we see that they have got various components. Okay, some of the components are pre-manufactured, and some of the components are assembled on site, and then some of the materials, the concrete, which are manufactured in situ. So in the same building, you have materials which are manufactured or placed in different ways. In each case, the satisfactory operation of building as a whole, okay, or in that case, for any structure, depends on the performance of the materials from which its components are made, as well as on how they interact with each other in the building. For example, in the building, you have got concrete, you have got cement, and then you have got reinforcement bar, okay, that some of which are precast, some of which are cast in situ. So in a building, actually during construction and after construction and for the service life of the building, how this thing will behave, okay, that we need to understand. So this is a question. This is a question, important question for the exam also. That before assessing requirements might include, okay, before assessing the suitability of any one material for given situation, the performance requirements for that situation must be identified. So, okay, so this is a question that, okay, if you choose any material, what are the performance requirements the material must fulfill? Okay, so first comes the safety. That means the ability to withstand stresses which will be coming from gravity. Okay, that means the weight of the material itself, then which will be coming from the wind, and then which will be coming from the maybe thermal expansion or moisture movement or other sources. So structural safety is very important. Then comes the safety of the occupants, the health safety. So there should not be any risk to health due to chemical or physical effect of the material, both during and after construction. So material should be such. You know, in our country, before maybe 2 decades okay, ago, still there are some structures you will find that the roofs are made of asbestos. Now later on it was found that asbestos is not actually good for health, because in long term actually asbestos causes actually okay, cancer. So nowadays we don't use asbestos as a roof material. Okay, so like this, so whatever materials you use, okay, the safety part of the occupants or those who will be living or who will be using, the users, so that thing you should consider. So one is called structural safety, one is called the safety or the health of the users. The fire, another hazard. So the material that you are choosing, it must it should be such so that, okay, it is in an acceptable range of resisting the spread of fire or the release of dangerous substances in fire, and to retain satisfactory structural stability. Okay, so for example, if a building is, if a house is made of wood, if the fire occurs, you know, it will spread very quickly. If it is made of concrete, okay, you know that concrete can actually does prevent the spread of fire, okay, for a certain time. Okay, and then there are some materials if you use, for example, okay, in some buildings, some part is made of maybe plastic. So that means burning, during fire, it will release dangerous substances, okay, which will cause problem for breathing or other issues. And then when in case of fire, actually once the fire is over, okay, so you know, you will have assessment of the building, and you will see that after fire whether the building is retaining its structural stability or not. So just for example, we can say that maybe a few months back you have seen in the newspaper that in Bonani area there was a building, okay, at that building actually it was subjected to fire. So after fire, whether the actually what is the structural stability of the building, okay, so that is being assessed. And in MIST, actually MIST as a part of consultancy is doing that damage assessment, and then MIST is given the responsibility to make the assessment of the building, because that building had fire, and whether that building is suitable anymore or not, and whether something can be done so that the building can be used. So those are the issues which will be coming. So the materials that you are using, you must see whether it is it can resist all those issues, or it can address all those issues or not. Then durability, very important. Material should fulfill the okay, above performance. That means the structural safety, health safety, and then fire resistance capability to some extent. Okay, and that will make the material durable. Okay, and then if the material is durable, then the structure will be also durable. And you know that for each structure has got some lifetime. For example, for a building, we say the 50 years is the design life. For a bridge is maybe 75 years or 100 years. So the material that are using in a bridge, for example, if it is made of concrete, so then over 100 periods of time, there will be deterioration of concrete. Now, if it is a steel structure, then from maybe after a few years after constructions, then those steel structures, if they are not maintained properly, so actually their condition will be deteriorate. And then so in case of this, some part will be under the water. Then when the material comes into the water, or if the structure is made in marine environment, so marine environment is different. So the corrosion is more in marine environment. Why corrosion will be more in marine environment? Marine environment will be learning. So that means here comes the term durability. Whatever structure you make, that will be made of some materials, then you have to see the durability aspect of the material. And in addition to that, one important factor is cost or availability of the materials. For example, in case of road constructions, nowadays we don't use big chips because of its low strength properties. We use stone chips. So for us, the main sources of stone is from Sylhet area, okay, from Dhulaganj across the border, okay, and then some of the stones that comes from the neighboring countries, and then we collect those stones and then we use it after crushing. That is one source. Another one is that in Dinaspur, in Muttopara, there is a granite mine. So we have stones from there also. That is of very good quality. Okay. So availability of the material. So if you don't have enough stone, in that case, maybe you have to actually import stones from abroad. So that will significantly increase the cost of the project. Okay. Then ease with which the material can be incorporated into the buildability. The materials which you are using, for example, if you think about a building, besides concrete, for plumbing, for electricity, and then there will be doors which will be made of tile or which will be made of wood, and then and there will be other fixtures in a building. For example, the facade, okay, that means the exterior of the building, actually, which will be nowadays in case of skyscrapers or high-rise buildings, you can see that the whole the facade is made of glass. So how best or how easily this material can be incorporated in the buildability. So that is also need to be considered. Then environmental aspect, very important, very important. For example, energy demand of the material during manufacture and ability to conserve energy in use. This topic will be covering in green building. We have a dedicated lecture for that. That for the time being, know that the okay, total energy actually, this is constant, and the stones, and then sand, then okay, and that means with which the inks of cement. The raw material of cement is the stones or the limestones. Okay, so these materials are not infinite, so they are non-renewable. Okay, so here comes that the whatever structure you make, so that should be energy efficient. That means because you have to go for some materials which will sustain for a longer period, and then the manufacturing process is also very good. Okay, good means environment friendly. And then once you complete a building, and because over 50 periods of its lifespan, actually the materials which are using, so whether they have got a bad impact on the environment or not, that also you should understand. So all those issues will dictate these three topics here, and in earlier slide there are 4 issues. So this will guide you in choosing material, okay, and these are the performance, okay, which you must consider once you choose materials.
Sir, assalamu alaikum, sir.
Bolo.
Sir, about the last point, sir, the easy.
Sorry?
Sir, after the availability, sir. After availability, sir.
Yes, ease with which material can be incorporated in the building.
Yes, not clear properly, sir.
Okay. For example, in a building, you have got, I said that there will be some water supply. For water supply, you'll be using some pipes, isn't it?
Yes, sir.
Water supply for actually for the sewage, okay, facilities from the building, and then for there will be some electric fixtures, and then the building may be made of concrete, but okay, nowadays in case of high-rise building, you'll see that the actually instead of wall in the outer part they use glass, isn't it?
Yes, sir.
Okay, so that means besides traditional engineering materials, we are using other types of materials also. So how best this material can be incorporated in the building? Okay, and how easily they can be incorporated in the building? Okay, so that topic, that issue I'm talking about.
Sir, understood, sir.
Okay. Here I'll cite one example of actually, few iconic engineering structures. The world famous Taj Mahal in India, Great Wall of China, then Twin Tower of Malaysia, Burj Al Khalifa of Dubai. So there are unique examples of civil engineering creations, and there are more in China. You know that in case of civil engineering constructions, now China is the lead country. Okay, they have so much of innovations, okay, in making structures. China, and especially nowadays Asia, China, Hong Kong, okay, and then Taipei. So these are the countries which are making the tall structures, okay, and then research work and the innovative actually ideas are coming up from these regions. Even in case of Burj Al Khalifa, which was made by lead was Samsung, South Korea. Then there are workers are from India, and then some part was made by the expert engineers of Hong Kong, and maybe the main engineer was from USA. So it is a multinational professional group. Okay, so we'll be talking about this. We'll be talking about Burj Al Khalifa later. You can see the Twin Tower of Malaysia. And Taj Mahal, okay, maybe constructed before 400 or 500 years. In case of old structures, actually, nowadays the way we can divide that, okay, this is the role of architect, this is the role of civil engineer. But in ancient days, actually, architects and engineers are more or less they are same. So the structure Taj Mahal or Great Wall of China or whatever, we claim that it is the contribution of civil engineers. At the same time, architects also actually they say that it is a contribution of them. But in old times, actually, these are all merged. Now, the present day, due to the sub specifications, now we civil engineers we know what is our job. So in this slide, actually, I'll be giving some information about the Burj Al Khalifa. I've chosen this one intentionally. Okay. So it is actually, it was actually, it is highest building, okay, at the time, and its architectural height is 828 meters, okay, and then is, okay, top floor is at 154th level. It has got an observatory, that means at 148 level, okay. The materials which are used in this building basically reinforced concrete is definitely the main. Then you see the glass, then the steel, aluminum. So these are the materials which are used in these buildings. And here in this building, there are 154 usable floors plus 9 maintenance levels. That means 9 levels are there which are used exclusively for maintenance purpose. Yesterday I was going to Wikipedia. It was maybe not 9, more than 9 levels. Okay. And then floor area, you can see huge floor area. And then in case of elevators, that means you're talking about the building. So if you in your building, you will be requiring the lifts and elevators. Okay. So here in this building, there are 55 single deck lift and 2 double deck lift. What is double deck lift? The lift that you usually see in our country or maybe in MIT, the single deck lift. Double deck lift means that 2 lifts will come. So one will stop in an odd floor and one will stop in an even floor. That means 2 lifts will come up together and go down together. This is called double deck lift. So these are some of the features of Burj Al Khalifa. And in total, the construction of Burj Khalifa required 330,000 cubic meters of concrete, and the foundation alone required 45,000 actually cubic meters of concrete. And here, a special mix of reinforced concrete with high compressive strength was used in Burj Khalifa. Special types of reinforced concrete was used. Its foundation consists of 192 concrete piles, and which are buried 50 meters beneath the surface. And then steel, in case of steel, reinforcement bar. So over 31,000 metric ton of steel reinforcement bar were used to reinforce the concrete. And in addition to concrete and steel, other major materials used like glass, silicon, and aluminum, which make up the outside facade of the tower. As I said that in case of high-rise buildings, actually nowadays, actually we do that. And the majority of the tower is a reinforced concrete structure with the buttressed core system. Okay, what is the buttressed core system? That means, okay, buttress means when one structure is being supported by another structure. For example, okay, so if this is the structure, so you need a buttress so to keep it standing. So that concept is being used in Burj Al Khalifa. Here in the layout plan, if I don't know that the study is available or not. Okay, that studies are not available here. So in the layout plan, actually, that means there are 3 wings, and then the 3 wings are laid in the which support each other. That's why it is called as a buttressed actually core system, and this system went up to 156 level, and then above level 156, it has got a structural steel braced frame, and then which gives an additional height of 230 meter, approximately, sorry, 230 meter tall actually structural gate. And the concrete strength of the tower columns and wall, it ranges from C80 to C60. C80 to C60 actually this implies the strength of the concrete. Okay, here actually they have used high strength concrete. Okay, where the strength of the cube was between 60 to 100 Newton per millimeter square, and the main application of high strength concrete, okay, which are actually in situ concrete constructions. Okay, normally high strength concrete are used for offshore structures, for the columns of the tall buildings, for the long span bridges, and other highway structures. Those high strength concrete were used in Burj Khalifa. And then, because the main advantage of this high strength concrete is that if the strength of the concrete is more, then you know that the reduction in the size of compression element actually happens, and then also the amount of longitudinal reinforcement, actually the requirement is actually lessened. And they used with ordinary Portland cement, with fly ash. What is fly ash? Fly ash is a byproduct from burning pulverized coal in electric power generating plants. Electric power generating plant, যেগুলো কোল বেসড প্ল্যান্ট, সেখানে বাই প্রোডাক্ট হিসেবে তোমার ফ্লাই অ্যাশ হয়। ফ্লাই অ্যাশ ইজ এ ভেরি ফাইন ম্যাটেরিয়াল। এই ফ্লাই অ্যাশটা সিমেন্ট হিসেবে ইউজ করা হয়, ঠিক আছে? ইট হ্যাজ গট সাম রেশিও, ইট ইজ ভেরি ফাইন প্রোডাক্ট। So in case of while they are preparing the concrete, so they use high strength concrete, and then cement, and then fly ash, and then other admixtures. What are admixtures? Admixtures use some special properties. Okay, we'll be learning about those admixtures. Okay, in the first class. And then in case of foundation, it has got 3.7 meter thick solid reinforced concrete raft foundation, and it is supported by 194 board cast in place piles. Okay, the pile diameter and then the length of the pile that you can see. Here they use the self-consolidating concrete, also known as self-compacting concrete, SCC. That means it is not the concrete which we see in our country. Okay, it is a highly flowable concrete that can spread into place. it can fill the framework. Normally, we fill the concrete in some framework, isn't it? So it rapidly occupies the space within the framework, okay, and it can capture the reinforcement. That means quickly it can make a bond with the reinforcement. In our case, normally when you use concrete or when you put it in a framework, then we have to go for vibration. Okay, either you do it mechanically or you do it manually. But here the concrete they have used, so you don't need any mechanical vibrator. Okay, so automatically the concrete will actually will be set. Okay, and then in case of conventional concrete which you use in our country, you need to go for vibration so that the segregation doesn't take place. What is segregation? That means when you in the concrete you will have aggregate. Some aggregates are larger, some aggregates are smaller. Then you will have sand and cement. So if you drop from a height, you will find that normally a man height, for example, is 5 feet. So if someone carries over his head, and if you drop it from a height of 5 feet, then there will be segregation. That means the coastal particles will get separated. It's number one. And then if you go for mechanical vibration, while vibrating, if vibration is not proper, then you'll find at the base of the column, there will be segregation. That means some form of honeycomb structure will form. That's why while casting concrete, that vibration is very important. So here, actually, they use self-consolidating concrete, which does not require any vibration. Automatically, actually, it is occupying the space and it is making bond with the concrete. Okay. And then at the same time, the type of concrete they use, the self-consolidating concrete or self-compacting concrete, actually the viscosity. Viscosity was moderate. Why? The normal concrete actually has a certain viscosity. What is viscosity? Viscosity is a property which is actually resist the flow. For example, if you take the example of water and honey. So honey is more viscous than water. That means honey resists flow. For example, if you want to swim in a pool, you can, if you are given the option to swim in a pool of honey or in a pool of water, okay, so you can swim very easily in a pool of water. It will not give any resistance, but it's very difficult to swim in a pool of honey, like that, something like that. So here the concrete they use, it has got moderate viscosity because it is necessary that actually, it was a high-rise building. So actually the casting is being done. That means the mixing of material is done at the ground, and it is necessary to take the materials up, okay, to that maybe 100th floor or 148th floor. So they used pump, okay, to pump the concrete to reach up to that height. So if viscosity is necessary, the viscosity should be moderate so that it can easily flow through the pipe, and then it can be at its proper place. That means placement purpose, okay, and then the other issues. And in case of Dubai, we are intentionally I'm discussing about Burj Al Khalifa chosen at the introductory class of material part, okay, because it has got some unique challenges. Okay, in Dubai, the temperature during daytime it is written 40 degrees centigrade. Normally, sometimes it is above 50, and during night time the temperature falls down. That is the characteristics of the desert area. Okay, so at that time, if you place concrete during very high temperatures, so what happens? Actually, the water actually goes away from the concrete very quickly, and that may cause cracking in the concrete. So it was necessary to keep the temperature of the concrete at a reasonable level. So that's why sometimes normally they used to do that concrete pouring at night when the temperature is low instead of day, and sometimes they use ice with the concrete so that the concrete remains cool. That means it doesn't get the temperature of 40 degrees centigrade, because that will cause problem. Because reason for using the reason for pouring concrete during night, or reason for using ice is that the concrete dries more evenly when cool, and it's less likely to form cracks. But if it is done in high temperature, so you will have those bad effects. And also the concrete's flow behavior, actually they have to keep in mind, because for that reason, to test it, a sample was poured onto a plate, and then it was seen whether the concrete can flow easily or not. You can see that actually the concrete was pumped from the ground to a height of 601 meters, and breaking the previous pumping record held by skyscraper in Taipei, Taiwan. That means 601 মিটার হাইটে কংক্রিটকে পাম্প করে উঠাতে হয়েছে। তো এটা করার জন্য তারা করেছিল, এবং যখন এটা কংক্রিট যখন এই ধরনের একটা পাইপের ভিতরে কংক্রিট যখন যাবে, তখন ইট উইল হ্যাভ লট অফ বেন্ডস। সো গ্রাউন্ডে তারা কিন্তু এই ধরনের তোমার এদের স্ট্রাকচার তৈরি করে কংক্রিট পাম্প করে দেখেছে, হাউ ডাজ ইট বিহেভ, দেন টেকিং লেসন্স ফ্রম দ্যাট, সো দে হ্যাভ গন ফর pumping up to 601 meters. And the pipe গুলো ইউজ করা হয়, এই পাইপের ভিতর দিয়ে কিন্তু কংক্রিট উইল মুভ। ওকে, সো পাইপের থিকনেস কিন্তু ইনক্রিজ করতে হয়েছে। দ্যাট মিন্স পাইপ গুলো ইউজ করা হয়েছে, পাইপের থিকনেস, ওয়াল থিকনেস was 11 mm, because due to the flow of concrete through the pipes, there will be some corrosion. Okay, there will be some damage. So that's why they have to go for a thick, pipe. So those are the challenges in Dubai. Temperature difference, this is one, and the soil itself, it is not good. Even after a few meters, 1 or 2 meters, they found very weak soil. That means limestone or very weak soil, and they had to take precaution for that also while they are considering the foundation part.
Sir,
So,
I have one question, sir.
Sorry,
Sir, one question, sir.
Bolo.
Sir, normally the standard period for the curing is, sir, 7 days, sir. Now,
Sorry.
what, sir? Curing of the concrete, sir. Sir, now in SCC, sir, is there any differences, sir?
In case of CC, then in case of RCC, there are various limits. 7 days. Then if it is a তোমার কি বলে যে তোমার roof slab, 28 days curing. So between 21 days, 28 days, there are various curing times of concrete are there. So you can reduce that curing time. Okay. So at that time, you don't use the conventional concrete. So when we will be talking about a cement lecture, we'll be seeing that there are various types of cement. Actually concrete curing মানে কি, সিমেন্টের কিউরিং এর উপর ডিপেন্ড করবে। সিমেন্ট কতটা কিউর করবে তার উপর ডিপেন্ড করে কিন্তু কংক্রিট কিউরিংটা হবে। So there are various types of cement. There are some cements which can cure very quickly. Normal conventional concrete যেখানে কিউরিং করতে 20 days লাগে, there's some special type of cement সেটা তো 3 দিনের মধ্যে ওই কিউরিংটা অ্যাটেন্ড করে ফেলবে if you change the properties of the cement. Okay, number one. এখানে যেটা হয়েছে in case of Burj Khalifa, so when they are casting যখন তার কলামগুলো যখন কাস্ট করে উপর দিকে যাচ্ছে, তো তাদের কংক্রিট গুলো কেমন করতে হয়েছে, তাদের খুব অল্প সময়ের মধ্যে এটা কিন্তু মোটামুটি একটা তোমার যে কি করতে হচ্ছে, তোমার কাস্টিং এর কথা যদি একটু ইমাজিন দ্য কাস্টিংটা, যে এটা কলামের কাস্টিং হচ্ছে। সো তোমাকে ফর্মওয়ার্ক করে কলামের মধ্যে তুমি কংক্রিটকে তুমি পোর করেছো, দেন আফটার সার্টেন পিরিয়ড that formwork is moving up. By the time formwork is moving up, নিচে তোমার যে কংক্রিট যেটা কাস্ট করা হয়েছে সেটা কিন্তু একটা সলিড শেপ পেয়ে গেছে কিন্তু, ঠিক আছে এটা। সো those are the challenges it was there. Okay.
Sir, understood, sir.
So there's a difference between a 10-story building and then 156-story building. And luckily, I had a chance to visit. Once I visited Dubai, I had a chance to be at 148th floor. Okay, that was allowed, and then they didn't allow more. So I had to stop at 124th floor and 148th floor, and I had a chance to see actually the completed one, okay, of Burj Al Khalifa. So if you have an opportunity, you must see, you do some study and then see, what is there, what they have made. Okay, but some of the actually the records of Burj Al Khalifa are broken by this time, in terms of height, in terms of observatory, some other structures came up. Okay, you can find those information in Wikipedia. So we are talking about that. In terms of material, we said that besides concrete, there are aluminum, silicon, and glass. So 132,000 square meter curtain wall facade of the Burj Khalifa is made of aluminum, silicon, and glass. Those things. You see, we're talking about the okay, how to feed that, this okay, buildability, and then how to maintain that. It is a huge affair, because you need to clean those glasses. This is the desert. And then ওখানে কিন্তু তোমার যে storm, তোমার sandstorm হয় কিন্তু, ঠিক আছে? So maintenance purpose কিন্তু they have dedicated people. Then এটা তোমার facility part আছে। এবং এই ছবিটাতে যদি যাই, তোমার এই ছবিতে যাও, so এখানে তুমি দেখো, so you have to maintain this part also. They have got specialized people who do this job. And I saw most probably Discovery and some other channels that how this maintaining work is done. Most probably some Indian guys, so they are responsible for most probably they're from Tamil Nadu. I forgot. So they are dedicated. So taking and it is done actually with it is very dangerous affair of maintaining the spine part, that means the steel structure part, the upper part of the ear, and then you have to maintain those facets. Okay. So continuous maintenance is required. So okay, you have got a structure. You are taking the pride that okay, I'm having the tallest structure of the world. But you see, there are there are subsequent maintenance issues are there. You have to maintain that. For example, in most probably in 124th floor, they had an observatory. Observatory means at a floor, যেখান থেকে তুমি এটা তোমার বুর্জ খলিফার ডাইরেক্ট এক্সটেন্ডেড ছিল, যেখানে এসে সবাই দেখবে, যে পুরো দুবাই শহরটাকে দেখবে। সো at one stage দেখা গেছে যে উইন্ডের যে এফেক্টটা আসে, তার জন্য দেখা যাচ্ছে এটা স্টেবল থাকছে না। সো দে হ্যাড টু আলটিমেটলি ওটাকে বাদ দিতে হচ্ছে, এবং ওটাকে তোমার মোস্ট অফ 124 লেভেলে কোথাও এটাকে ইনসাইড নিয়ে আসতে হচ্ছে, বিকজ ডিউ টু দা দুবাইয়ের যে ক্লাইমেট এবং ওখানে যে উইন্ডের যে এটা হয়। Even when the whole building was designed, how wind direction take তারা কনসিডার করেছে। সো বিল্ডিং এর ডিজাইন করার সময় স্ট্রাকচারাল পার্ট কে গভর্ন করেছে বিল্ডিং এর লেআউট অর ওরিয়েন্টেশনটা কেন, উইন্ড ইফেক্টের কারণে একটা 156 স্টোরে হাই রাইজ বিল্ডিং কিভাবে বিহেভ করবে। সো আর্কিটেকচার এন্ড দেন উইন্ড পার্ট, this part governed what the structural part in case of Burj Al Khalifa. ঠিক আছে, যে উইন্ডো ইফেক্টের কারণে সো হোল ডিজাইন প্যাটার্ন চেঞ্জ করে ফেলতে হচ্ছে কিন্তু, এন্ড দেন স্ট্রাকচারাল এলিমেন্ট গুলোকে তার সাথে তোমার যে তোমার কি বলে কমপ্লাই করে যেতে হচ্ছে। নরমালি কি হয়, in case of a construction owner, the client gives a requirement. Okay, I want a building like that. Now then architecture comes, he designs the building, then he sets a tough actually situation for the structural engineer. Then there is a tug of war between the architect and the structural engineer, and at the end you get something. Okay, and the finished product is the actually the contribution of the owner, his dream, then the dream of the architect, and the structural engineer or the electrical engineer, they have to adapt, though they are not happy, but it is challenging. And then, but they have to overcome that. Okay, and then it happens, and that's why you find that the relationship between architect and civil engineers are not that much good. But once they finish a project, once it is visible, all of them take pride in that. Okay, and then okay, so I was talking about the outside facade. So it consists of about 24,000 panels, especially designed to save energy. So if facade কিন্তু আবার multiple use আছে কিন্তু, it's not that I have just used glass. What type of glass I have used? এই গ্লাসে তোমার যে সানের জন্য যে তোমার যে হিটটা আসছে কি পরিমাণে রিফ্লেক্ট করবে। সো সিঙ্গেল লেয়ার গ্লাস আছে, ডাবল লেয়ার গ্লাস আছে, ট্রিপল লেয়ার গ্লাস আছে, ঠিক আছে। এবং হোল স্ট্রাকচারের মধ্যে তোমার যে সানলাইটের জন্য কিন্তু কি হচ্ছে, তোমার এটাতে গরম হচ্ছে, তাই না? তো টপ গ্রাউন্ড ফ্লোরের হিট এক ধরনের, টপ ফ্লোরের হিট কিন্তু আরেক ধরনের। সো এই পুরো জিনিসটা কিন্তু কনসিডারেশন নিয়ে দে হ্যাভ টু ডিজাইন দ্য বিল্ডিংটাকে তোমার ডিজাইন করতে হচ্ছে। সো এখানে যে গ্লাসগুলো ইউজ করা হয়েছে সেটা কথা বলা হয়েছে, their high performance reflective glazing greatly reduces heat transmission, which is a critical feature in the extreme heat of Dubai. তো গ্লাস যেগুলো তোমার আর্কিটেকচারাল বিউটির জন্য হোক বা বিল্ডিং এর তোমার তোমার যে লোড ডেড লোড কমানোর জন্য হোক বা বিউটির জন্য হোক, তুমি কিন্তু গ্লাস ইউজ করছো কিন্তু এখানে ইনস্টেড অফ নর্মাল ওয়াল, তাই না? বিউটির জন্য তুমি করেছো। সো এটার কনসিকুয়েন্স কি হচ্ছে? তো নর্মাল কংক্রিট ইউজ করলে এক ধরনের কিন্তু হিট ট্রান্সফার হতো, কংক্রিট হিট রেজিস্ট করতো। বাট ওয়ান্স ইউ ইউজিং গ্লাস, হোয়াট এভার গ্লাস আর ইউ ইউজিং, এবং গ্লাসের উপর ভিত্তি করে কিরকম হিট জেনারেট হচ্ছে ইনসাইড দ্য বিল্ডিং, তার মানে তোমার এয়ার কন্ডিশনিং সিস্টেমটাকে কিন্তু এর সাথে কিন্তু অ্যাডজাস্ট করতে হচ্ছে কিন্তু, ঠিক আছে। এবং ইট ইজ ইন দুবাই, which is not a very good place for the civil engineers. That means when you construct something in Dubai, so that is the challenge for the engineers, okay, civil engineers. So they have overcome all those issues. They have overcome all those issues. Actually, the team which was working there, actually, they are the same team who are engaged in construction of some of the high-rise building, okay, maybe 100-story building in Taipei or some other part of Asia. So they are called, and then there are idea competitions, and then there are various challenges that overcome. We are talking about the material part.
স্যার
বলো।
স্যার আমাদের স্যার 12:45 স্যার একটা ক্লাস আছে স্যার।
Okay, ঠিক আছে। So that's all. So this is the initial lecture. So we learned about material in general, rationale of the course, and discussed about Burj Al Khalifa in general. And then from next class onward, we'll be discussing, we'll concentrate on the constitute of concrete. That means actually the aggregate part. Aggregate part we'll be considering. Thank you. You may leave.
আসসালামু আলাইকুম স্যার।
Assalam.